Okay, now we're at 60 to 1. Every time the wheel rotates one time, the stator goes 60 times. So we're on a 60-inch to an 8-inch to a 12-inch to, I think that's a 4-inch over there, to a 14-inch to a, I think that's a 6, or that's a 5, I think. So it's bigger now. That's a 4, that's a 5. So 60 to 1, and our wheel's spinning about 5 rotations per minute, which puts us at 300. So we're right about 300 no matter what we do. One way I can fix that, I think, is to put more bigger buckets in the, let's jump up here, I'll show you. Put bigger buckets the big bucket is hardly getting any. Well, I don't know, bigger buckets ain't gonna help much. I'm guessing the bottom bucket holds probably half a gallon. It wasn't actually a bucket that's turned sideways. And the top went to 2x4, so I can maybe put a bigger one at the top. To be that one right there. It's just overflowing at that rate. Alrighty, so here's the truth. 121 volts, 130 volts off of the water wheel with the factory stator. Haven't done nothing to it. The water wheel is, or the stator is moving about 300 rotations per minute. Okay, so there's our volts. Getting 0.4, nothing, 13 watts. This is at 48 volts on this Sun Gold. 15, and this is just the water wheel. I'm not using the solar on it. This is just tied into the water wheel. Not getting hardly anything at it, but so I'm guessing that water wheel's got to spin a lot faster to really produce much of anything. We have 8-gauge wire feeding the rectifier, 8-gauge down into this. I guess the smallest part would actually be, smallest wire would be actually the wire in the stator. This 8-gauge wire is going about 300 feet. But it's about the same numbers when I had 12-gauge wire, so I don't know. Hey there, guys. I just want to point out a couple things on this. Number one, I'm using the factory stator motor off the washing machine because the stator motors that I rebuilt just didn't put out enough voltage to actually activate the charge controller. The charge controller, I think, takes 70 volts of DC power for it to actually work and do what it's supposed to do. So we're using the factory stator. I do have 2 other ones that I've rebuilt. One is they're 36 coil, I guess you call them, stators, and I rebuilt one so it is 4 groups of 9, which would put out more amperage and less voltage, and it is. It's like 45 volts. Excuse me. The other one is 2 sets of 18, which puts out twice the amperage and half the volume and half the voltage. They just weren't enough voltage to run that charge controller. So that's one thing. The other thing is, on this video, there's a spot where we see the motor or the wheels turning like 320 RPMs or something like that. But in that point, I did not have the load on the motor. So when I actually put the load on it, it really slowed down to a crawl, like hardly moving. So we ended up with this last gear ratio, and it's about 250 rotations per minute with our 4-inch line that comes down. It's about half full. That feeds the flume. Anyway, guys, let's get back to the video. Thanks. All right, so we did gearing again. For every 1 rotation of the water wheel, that pulley spins 35 times. Right now we're spinning about 5.5 seconds per rotation, which puts us at about 10.5 rotations per minute, which puts us roughly at 380 RPMs. It's got this plastic here because this is leaking right above it. And up at the house, or right here, on these, right here at the jumper, those wires I'm getting 0.7 and 0.6 amps, 3-phase power. And up at the house, I'm not getting nothing. So I'm thinking this 12 gauge wire just is not big enough, this temp wire. So I have that 8 gauge wire I'm going to have to pull, but I really want to dig the ditches before I went any farther with it, but looks like I'm going to have to do that before we get an accurate reading. Alright, so guys, this one was actually a pretty good ratio, but as soon as we put a load on it, that bearing, that pulley you see right there, that small pulley, it basically stripped and it would not hold as soon as we put a load on it. So that did not work for us, only because I didn't have another pulley that size. But it put a pretty good load on it. And then the next one we tried, we tightened that down and put the other pulley on there, the 5-inch pulley, and it held. But then the pulley around the corner, the 3-inch pulley that's up in here, it started stripping and I couldn't get it to hold no matter what, unless I welded it, and I wasn't about to weld it. And then if even I welded it, then the belt started slipping on it because it's just too much of a draw in the gear ratios. Let's get back to the video. All right, so we're going to redo our gearing again. So right now, with a load on this thing, it's turning 50 to 1. Every time that wheel goes around one rotation, this goes around 50, which is giving us, let's see if I can test this. Giving us about 164 rotations a minute. So we're going to kill the water on it, and we're going to switch out that. I think that's a 4-inch. I'm making a 6-inch. So it'll be 60-inch, 8-inch, 12-inch. We'll change that to a 6, and then a 12, and then another 6, I think. It might be a 5. Anyway, we're going to do that now. Okay, switched out that for a 6-inch. We lowered our gear ratio, so it's now 1 rotation here equals 32 rotations on this spindle. So every time that goes around one time, that goes around 32 times. Let's go turn some water on. All we do to throw the water on is just throw this, like we showed you before, we just throw this tube in there. Hang you up right here for a second. Just goes up in there. So our flow is just down the flume, and it's a little more than half the volume of that. When it's actually raining hard, that'll flow up to about 3/4 volume. I want to spin that wheel the other direction, get her started. So I don't know if that's been any fast. Let's take our gauge and see if we're any faster. There is a load on this. It is hooked up directly to the batteries. $165, 171. So it did speed it up a little. So 165, let's say 160 to 170. Constant rotations, but there's not as much torque. Because that down there had a lot of torque on it before. It would actually run for a little bit and then it would just stop, and that belt would start spinning because it was too small, too much torque. So this is about the average rainfall we have through fall and spring. So that's about the flow we would have. We did take out half the buckets. So now we have 16 buckets, and the smaller one has a 2x4 screwed to the face of them to be more like a bucket to catch the water. Take you over to the other side. I'll zoom in so we can see what we're talking about. Because before, without that little 2x4 on the front of them, they were just filling up and dumping out way too early. So now, I need to seal it. You can see I haven't sealed anything on it. So the buckets are filling up, and the water's staying in there longer. So, let's go up to the house and see what it's actually producing. I'm guessing 30 watts. Go up to the house. Alright, so this is the charge controller our water wheel's hooked up to. We're only on the water wheel. It's putting out 81 volts, almost 82 volts, which is supplying 55 watts to the batteries. And it's producing 0.6, 0.5. So it's 39, 35 watts, 38 watts, 35 watts, 27. So basically that wheel's spinning 5.3 rotations per minute, which is giving us 170 rotations on the motor, on the generator. So if we had more rain flow, more water flow through that pipe at 3/4, I would guess that this would go up a little, but this is with the load on it, and it's just, just the water wheel. So that is 45 watts of continuous power 24/7. I mean, it's not a lot, and amp wise it's like a half an amp. Like right now it's not even using it because the batteries are fully charged. Let me actually turn off all these other ones, make sure we're not limiting in this charge controller. So now that I turn off all the other charge controllers are turned off. So this charge controller is pulling 1/3 of an amp, or pushing, not pulling, it's pushing power to the batteries to charge them. Right now in the house is running 30%, so it should have a pretty good draw. Let's see what they're actually drawing. So the system is drawing from the batteries 76 DC amps to run the inverter right now. And so this should be putting out max that it can give, which is 1/3 of an amp. Right now it's only at 13 watts, 15 watts, 28 watts. See what our voltages are still the same. Yeah, 99 volts. That voltage actually went up. But it might be saying, hey, the batteries are full. There's half a watt. I mean, half an amp down. So it's basically, the wheel could be slowing down, speeding up a little from the load. Like when this says, oh no, we're full, it takes the load off of the system. And then it might speed up maybe. The wheel might speed up because there's no load on it. Because this basically shuts off the load to the batteries when it's full. So when it actually says, no, give me some power, it might be saying, give me, like now it's at 0.6. I really don't know, guys. I just can't get any real power out of this. Like I said, it's 3-phase coming up here, and that's number 8. It's 3-phase AC, number 8 gauge wire. It's about 300 feet. Then it goes into this rectifier, which converts it to DC power. And these are number 8s coming down. Number 8, I mean, number 8 should be more than big enough to haul the small amount of amperage that washing machine motor is putting out. Like right now it's at 0. 0.7. Let's go out and see if that wheel's slowing down, speeding up. Let's let it run the way it is. Right now it says 1 watt, 7 watts. Yeah, let's go see what that wheel's doing. Okay, so this is not moving. I mean, it's spinning pretty good, but it sounds like I got a bearing going out in this pillow. So I got another one of these and replace that. This is definitely grinding. Let's see what we got. So it turns out that bearing right there, that pillow bearing, was bad. I happen to have another one. No difference. Just let's see what we get now. Oh yeah. From 170 to 250 rotations a minute. Let's go see what we get up above. All right, so we got wheel spinning a little faster, but it is not making any difference here. We're at 18 watts, 21 watts. Shoot, we were at 35, 40 a minute ago. Amperage, let's see what we got for our voltage. Voltage, 113 volts, 91 volts, 85 volts. It's kind of all over the place. We are just on the water wheel, pointing up. Wow. So that's 12 amps a day we're feeding into this DC power. So I mean, it's something. Anyway, that's until we get a little bit more water flow down that, and don't think that's going to happen this week because it's supposed to be sunny all week. So that's about the most water flow we're probably going to get out of that water wheel. Probably till next fall, probably is about that amount. So, but that's a half an amp every hour. You know, 0.61 to 0.6. That's more. And then, anyways, that's 12, 13 amps a day in a 24-hour period because it's nonstop. So it's something. Wish it was more, but it's not. Have a good day, guys. So this is still just a water wheel, just to verify that those numbers are about the same. This is just a water wheel, amperage coming through the bus bar system down to charge the batteries. And we're anywhere from, we're all over the place, but mostly up about 50, 35. Had to balance out maybe because I just turned all the solar back off. So now it's just the water wheel coming through the whole system. And that's 0.49 of an amp per hour. So like I said, in 24-hour day, that's about 12 amps. Have a good one, guys. Okay, guys, so I went down to the creek and checked, and that new bearing, or that new pulley we just put on, it was slipping. So I torqued it down as tight as I can get it and came back, and we were getting about 0.6 constant when it stops, when I got it to stop slipping. Anyway, on with it. Okay, so what we ended up with was 60-inch wheel to an 8-inch wheel to a 12-inch wheel to a 6-inch to a 12 and up to a 5. And that's spinning about 12 seconds per rotation, which is about 5 rotations per minute. This is at 35 to 1, which is going to put it over as 30 to 1 be 150. So it's probably about 170 rotations a minute on the factory stator. We had a spot where we had it going to a 12-inch here, to a 6, to a, I'm sorry, from a 12 to an 8, or from a 6 to a 6, then to a 14, and then or something like that. And it was giving us more rotation. We might try that later, but right now, this is what we're at. Pretty good draw in, and there's a load on it right now. Alrighty, so here's our water wheel. What would I do different if I was to rebuild this and start from scratch? Number one, I would build the wheel identical like I did this one with 2x12s in the middle. But I would add a whole nother wheel attached to it. I would basically just put another 7-foot rim on it, do another plywood, and just rebuild the whole thing exactly the same. With the buckets though being not probably lined up identical, probably half of what they are, maybe, I don't know. But then I'd just build the flume and split the flume so it was actually hitting 2 wheels tied together on one pulley to give you more torque. But you got to have the water flow to do it. But that'd be the most cheap and economical way to do this, I think, with wood. Anyway, fun project. Okay guys, I'm not saying I'm gonna rebuild this thing, but if I were, or if I was to start and do it a different one, another one, I would basically build 2 wheels, bolt them together, the same size, everything, bolt them together, so you know it's spin and one pulley running, and then I would have 2 4-inch flumes come down, at least 4-inch, maybe 4s, and I'd have a bunch of more flumes come down to catch that water. But that's about all I would change on it. I would definitely do the washing machine motor, because if you get it spinning fast enough, that is your best option. For us, it's just we don't have enough. It doesn't have enough torque to spin the pulleys, and I would maybe probably do chain-driven pulleys or double pulley on stuff, because it just one pulley will slip when you start getting enough torque on it. Have a good one.